Hello, hello, good morning. Welcome back. It is Monday, the 16th of March, and today I'm finishing off the OCR math paper A-level summer series from 2024, going over paper 3, the pure math and mechanics. And today, guys, I gotta tell you, I'm in a great mood because I slept very, very well. Ooh, hold on, let me turn the lights up a little bit. There we go. Which does not normally happen. I'm very, very talented at so very many things, but sleep has never been one of them. And so, yeah, it's just been a lot of like, my body bails, man. It bails like like one sleep cycle early, and then last night I was like, do you know what? I'm just gonna do it, and then like got to 8 a.m. Went, no, I'm not gonna wake up at this time, and just let myself get back to sleep, and it worked. Hold on a minute. We got a little bit of camera disruption because my desk is too high. There we go. Good to see someone in the chat already. And yeah, I don't think I need to bore you too much with my sleep, but I'm in a great mood. And so I feel like today's paper is going to go great accordingly. Apologies for not giving enough notice on this one. I do promise to try and be better in future, but this is why we also have a Discord server with me, so I can kind of give last minute notifications if I go live in this sort of fashion. I do have a session at 1:30. These papers do take a long time, so I'm not going to waste too much time. I think I'm just going to get my timer up on my phone for the 2 hours that it's going to take to do this paper. I do still have the calculators waiting in the wings on the second monitor. Got my paper. I have my answer booklet, and I say we just get into it. So if I share this entire screen too, yep, you can see the question paper. You can see the answer booklet. I am going to start the clock now. So let's get into it. Right. First thing right off the bat, some nice power law stuff. On the first one, let me zoom in just so it's a little bit bigger. And I'll be playing around with the formatting just to make the visual okay. So the first things first, that cubes the entirety of that bracket. So that is going to turn into 8. Oh, pen thickness. So the 2 cubes up to 8. The a squared cubes up to a to the 6. Actually, do you know what? I preferred the thicker. I think it looks better on the screen. Just for contrast. Okay, so 8a to the 6 times the 3/4, a to the -1. These will cancel down to give me 2, so it will become 6, and then a to the 5. With the 6 and the -1 combining to give me 5, because when I multiply, I add the powers. Part 1b. I look at that top. I know this is algebraic fractions. Immediately, I'm thinking I'm going to have to factorize and then cancel. The top is a difference of 2 squares, so that's 2x plus 3, 2x minus 3. And then on the bottom, that factorized. Okay, so my target number here is going to be 2 times the -12, which would be -24. Yeah, that would be plus 8. Plus 8 minus 3. So that would be 8x minus 5x. I'll show you how I did that. But that cancels down, and you just get 1 over x plus 4. I may as well show it now. So in my head, factorizing harder quadratics, that's going to be 2 times the -12. So my target number is -24. I need numbers that multiply to -24 and add to +5. That is going to be +8 minus 3. And there's a cool trick from the IB to make this speedy, where I just do 2x on both brackets. So 2x plus 8, 2x minus 3. And then divide the whole thing by 2. And then the 2 canceled with the 2x plus 8 to give me this x plus 4. Just a nice way of going through without wasting too much time on it. Right, let me scroll out so I can see this question for a bit. So question 2. Show detailed reasoning. So you could do this with the calculator if you were more skilled than I. So the diagram shows a sector of a circle with center O and radius 3x plus 1. The angle is 2 radians. The area is less than that. Okay. So we know that the area of a sector is given by the formula A equals 1/2 r squared theta in radians. So it would be a half r squared theta. So it would just, and the half and the 2 will cancel and just give me 9x squared plus 6x plus 1. So that is the area, and we know the area is less than 44x minus 7. So this thing, the 9x squared plus 6x plus 1 is less than 44x minus 7. So this is going to give us a quadratic inequality. This would be minus 30. In fact, I've got a calculator. And I'm not going to show you like the really simple stuff where I just do 6 minus 44. You know how to press those buttons. But yes, that is minus 38x. Add that across to give me 8. Now, this is a quadratic inequality. Immediately, I go, okay, I know how to do quadratic inequalities. You have to sketch it. And by sketching it, you will then see where the curve is above and below. And the first thing you got to do to sketch it is to find out where these 0 points are. So same thing again, I'm going to multiply the number in front of the x squared, the a, by the c. Target number is 72. And I'm getting minus 38 from that. So that would be minus 36 and minus 2. So I can factorize that to 9x minus 36, 9x minus 2, all over 9. The 9 cancels with the first term, so it would be x minus 4, 9x minus 2, having to be less than 0. So when I sketch that, I know I'm going to have a curve that does something like this, where it crosses at 8 on the y-axis, and it's going to cross at 2/9 and at 4 on the x-axis. And where is this curve less than 0? Between 2/9 and 4. So the region I'm looking for is that 2/9 strictly less than x, strictly less than 4. Okay, let's move on to question 3. 3a, so we're expanding, okay, binomial expansion with fractional or negative powers. There is a formula for this. I think this paper has formula books, yeah, up here. So this is going to be this second year type up here. So I'm just going to apply that formula here, and I should be completely fine. So it's going to be, if I zoom in once more, where are we going up to? We're going up to and including the term in x squared. Okay. So I'll give myself some more room because obviously I'm going to need lots of terms. But 3 minus 2x to the minus 2 will be equal to, God, can I remember it? I used to definitely have this memorized, but it's oh, of course. This only works where there's a 1 in the left-hand side, so I do not currently have that. I have to factorize out a 3 to the minus 2, and I'm left with 1 minus 2/3 x to the minus 2. That's because I've taken, maybe if you need to see it a bit better, what I can do is I could take a 3 outside that entire bracket. When I do that, you'll be left with 1, because you can see if I expand this bracket back out, I will get 3 minus 2x. And the whole thing is to the minus 2. Now, 3 to the minus 2 is a 9th. And then that's 1 minus 2/3 x to the minus 2. Now, I can apply the formula from the formula sheet. So it's going to be a 9th into, now, in fact, let me do this across 2 lines so it's a little bit clearer. So this will be a 9th into 1 plus n x term plus n minus 1 all over 2 factorial, which is 2, times the x term, which is minus 2x over 3, all squared. And then I can close this sort of big bracket outside the front. So it's a 9th into 1 plus 4x over 3. And this becomes 6 over 2 is 3. So that's 3 into 4x squared over 9. And then we just simplify. So it's 1 plus 4x over 3 plus 4x squared over 3. So it ends up being a ninth plus 4x over 27 plus 4x squared over 27. Okay. Right, bringing it back across so I can find the question. Going back to question 3b, state the set of values for which this expansion is valid. This is a classic. So if we go back up to this formula that you need to use, this is only valid when the magnitude of x, the thing at the back of the bracket, is less than 1. In our case, we had minus 2/3 x. So what we need is for the modulus of that thing, the minus 2/3 x, to be less than 1, which means that, and the modulus, so it's 2/3 mod x less than 1, so the modulus of x has to be less than 3/2. That's when this thing is valid. So going back down for 3c, when this thing is expanded in ascending powers of x, the coefficient of x is 0, find a. Well, that thing is a plus x into 3 minus 2x to the minus 2, which is relevant because that second part is the expansion we just found. So the coefficient of the x is 0. Okay, so I'm going to need some room here, so I'm going to move this across. So this is going to be a plus x into what we just found, which was a ninth plus 4 over 27x plus 4 over 27x squared. And we actually don't even need to do the entire expansion here because we know the coefficient of the x term is 0. So to find the x term specifically, it's going to be a ninth x from that, and it's going to be plus, well, in fact, let me make this a bit clearer by doing it on more than one line. So it would be x over 9 plus 4a over 27x. And we know this is equal to 0 because the coefficient is 0. So what we know is that 4a over 27 is equal to minus a ninth. So 4a is equal to minus 3, and a is equal to minus 3/4. Just make sure I answered that correctly. Ascending powers of x, the coefficient of x is 0. Okay, I'm happy with that. So let us now move on to question 4. We immediately get some trigonometric identities. So we want to show that this equation at the top can be written in the form of this equation on the bottom. So immediately I'm thinking cosec cot are in the same sort of trig family. I know I can never be bothered to remember them. Let's see actually if your formula book gives you them. I don't think it will. No, those are the only trig identities you get. Oh, no, that's differentiation. Okay. So what I always have to do, because I can never be bothered to memorize them, because is I always just derive them from first principles. I know that sine squared plus cos squared x is equal to 1. And I make a cosec and a cot by dividing by sine squared. So if I divide both sides by sine squared, you get 1 plus cot squared equals cosec squared. So that means I can convert my cot squared into cosec squared. And the reason I do that is because then you get the entire thing in one trig term, but also I know cosec can turn into sine. So let's get it into cosec. So this whole thing, so it would be 2 into cosec squared x minus 1 minus 9 cosec x minus 3 equals 0. So it's 2 cosec squared x minus 9 cosec x minus 2 minus 3 is minus 5. And I can multiply both sides by sine squared. Or rather, I'll just explicitly write that as 2 over sine squared x minus 9 over sine x minus 5 equals 0. So I'll now multiply by the sine squared to get 2 minus 9 sine x minus 5 sine squared x equals 0. And then by moving the entire thing over to the right-hand side, you're left with 5 sine squared x plus 9 sine x minus 2 is equal to 0. So then in B part 1, again, you have to show detailed reasoning, implying it could be done on a graphing calculator with some skill. Hence, solve for 2 theta is immediately what I see. I see x is equal to 2 theta. So I'm immediately going to transform my interval so I know what I'm looking for. So it's between 0 and 2 pi. And then I know I can rewrite this equation as 5 sine squared of 2 theta plus 9 sine of 2 theta minus 2 equals 0. Or again, I can use my trusty trick for factorizing harder quadratics. So 5 times minus 2 is minus 10, which is minus 10. So sine theta, it's minus 10 and plus 1 all over 5, where the 5 will cancel out with the first term and give me sine 2 theta minus 2, 5 sine 2 theta plus 1 equals 0. And I can just check that that's minus 10 plus 1. Great. That does factorize correctly. And yeah, it's just continued. Great. So we know we either have sine 2 theta equals 2, which has no solutions because the biggest thing that sine can ever get is 1. Or we have sine 2 theta equaling minus a fifth. And that's the thing we're going to solve for. So I'm going to take it over to the other side now and say that 0 for 2 theta and 2 pi. We're solving for sine 2 theta equaling minus a fifth, I believe. Let me just check that was right. Yes. Yeah, okay, so sine 2 theta equals minus a fifth. Let me go to the calculator, and in fact, this is one where I'll actually take this across. Let me make sure, first of all, I'm in radians, so mode, nope. Guys, the buttons literally on the first button click, done got me. So we're gonna go shift menu so I can change my angle unit to radians, and then make sure I do inverse sine of minus a fifth. So I get a first value for 2 theta of minus 0.201. Now, my preference is always for cast diagrams, and in fact, let me just move this across. So my preference is always for cast diagrams over the trig graphs. So I'm going to draw mine out, CAST. We know sine is negative, which means I'm looking in the C and the T region. Minus 0.201 is going to be this initial C value, but it is not in the interval. So how do we convert the other ones? Well, what I can do, first of all, is to say that would be based on an A value of 0.201. And so I know that T is going to be equal to pi plus 0.201. So I'll do minus answer to get it to the positive, and then we're going to do pi plus that answer to get, in the interval, 2 theta is going to be equal to 3.343, or the second value will be, if I just get that answer back in, because I like precision if I can, so I'm going to redo the inverse sine of minus a fifth to get that C value. And to this, I will simply add 2 pi to bring it back around to the other C value in the given interval. So we're going to add 2 pi and get a value of 6.082. And we divide both of these by 2. So this one I'll divide by 2. 3.04, I'll call that. And this one I'll just call 3.343 divided by 2 is going to give me 1.67. No, they said correct to 3 decimal places. Blah. Okay. In which case, I'll add the 1 onto that one. And this one I rounded on the way, which I shouldn't have done. So really annoyingly, I'm going to have to redo it because I should have been more precise. I thought I was being sufficiently precise. Inefficiency is inefficient. Okay. So that one we're going to do 3 and then divide that thing by 2. Okay, so it's 6, 7, 1. So if now, how could I have got around that, by the way? What I should have done is to say if my final answer needs to be correct to 3 decimal places, that still doesn't even help. Because I was going to say, okay, well, therefore, every answer on the way needs to be correct to 4 decimal places. But if I had done that, it would be 3.3430, which like wouldn't have helped me work out which way I had rounded towards that to know which way this was going to go when I divided by 2. So just kind of do it as you go, I think would be the answer. But right, we found our 2 thetas, correct to 3 decimal places. Yay us. Okay. Whoop. All right, so now we've got a part 2 on that B. The small angle approximation for sine 2 theta is used to find an approximation for the smallest positive solution of that equation. Show that this approximate solution is accurate to 2 decimal places. Okay, so we have that guy, which was the sine guy. So we're going to use our small angle approximation on this sine thing. And say that sine x is approximately x in small x, which means that 5x squared plus 9x minus 2 is equal to 0. And we have to show it's correct. Show that this approximation is correct to 2 decimal places. Okay, well, I'm just going to have to solve for that. So this would be, I think we've even seen this. This would be 5x minus 1x plus 2 into the, so x is equal to minus 2 or x is equal to 0.2 is accurate to 2 decimal places. I feel like I'm missing something. Let me zoom out. Because if I have that, oh, but it's 2 theta. No. Okay, so it's not this. Sorry, apologies. Apologies. Because that is true, but we do not have it in x. So let me just erase this. Because immediately I was like, red flag, I'm not getting answers that look like this. So I'm just going to try this again. Because I should have taken the equation in theta, not in x. So the equation in theta, like I wrote up here, is this guy. So the equation I've got is 5 sine squared of 2 theta minus 9 sine 2 theta minus 2 equals 0. And again, let me just scroll up and check. Oh, no, so that was a plus. It was 5. Yeah, plus 9. Okay. So transcription errors are surprisingly common. Like as soon as you're copying across, that's when you got to be like extra vigilant, right? So we want to show that this approximation is good. So what this means is that will become approximately equal to 5. That will become 2 theta squared plus 9 into 2 theta minus 2, which is 20 theta squared plus 18 theta minus 2 equals 0, dividing both sides by 2, which approximation has been used quite right. I wasn't as explicit as I could have been and should have been. So what I used here was the approximation that sine x is approximately x for small angle approximation, because that's what the question is asking for. And that means that sine of 2 theta is approximately equal to 2 theta. So wherever I saw sine 2 theta, I replaced it with 2 theta. So sine 2 theta becomes 2 theta all squared. And that sine 2 theta became 2 theta as well. So now we have this new quadratic we have to solve in theta, and that will be 10 theta. That'll be plus 1 minus 1. So theta equals 0.1 or theta equals minus 1. But again, the answer wasn't... Am I missing solutions here? This indicates I've done something wrong. The smallest positive solution of the equation, which means I should have got something close to 0.1. I did not get anything close to 0.1. Interesting. Did I do this wrong? Let me give this a quick check. Hence solve for 2 theta of this thing. Well, that thing is 5 sine squared of 2 theta plus 9 sine 2 theta minus 2. Does this thing that I found factorize or expand back out into this? So 5 sine squared. So I got my signs wrong. It was plus. It was plus. So I did it for minus 9. Ooh, okay. Really glad I found that. And I would have caught that anyway when I checked by putting my answers back in. So let me show you how my checking could have caught that, right? So let's say I've got my calculator back out. So I could have done... So this guy, all right, let's divide this by 2. So this is a solution, right? So this is I think this would be a solution in theta. I should be able to plug that back into the original and get 0. So 5 into sine 2 answer, close the bracket, all squared, plus 9 sine 2 answer minus 2. I do not get 0, therefore that answer was wrong. So I immediately would have gone, okay, something went wrong here. And the answer is that should have been a plus 10. And this should have been a minus 1. So let me go and change my signs throughout. So this should have been plus 2. This should have been minus 1. This should have been a fifth. This should have been minus 2. This still has no solutions, but we should have solved for sine 2 theta equals a fifth. So let me try that. So inverse sine of a fifth, I'll just call it 0.2. So it would have been the positive of this. Well, okay, so 2 theta equals 0.20136, because I'm not falling for the accuracy points again. This, sorry, the precision point that I came across last time. Now sine is positive, so we want the A region and the S region. Now the S region is going to be found by pi minus this thing. Well, actually, first, while I'm here, I'm going to divide it by 2. So theta equals 0.101 and multiply it back by 2 to get to the original, and then do pi minus answer. And you get 2.94023, which when I divide by 2, correct to 3 decimal places, I'll get 1.470. Now, 0.1, 0. So 0.1101 equals 0.10 to 2 decimal places. I agree. So apologies for the little execution error there, but at least I caught it. So it is accurate to 2 decimal places. Great. Okay. So after that little snafu, which we found very quickly, let's move on to question 5. Okay, so we have a diagram with a curve. Let me zoom out so I can see the equation. We know a curve has a point of inflection, which means the second derivative is 0 at point M. and we have to find where point M is. So that means we have to find where the second derivative is 0, and this is just going to be some differentiation work. Okay, so this is what we got. Can I zoom in one more, or is that going to make it all? That'll work. So we have to find the point of inflection. Oh no, that won't work because I've got to give myself some room to actually work. Okay. So we have y equals x cubed minus 2x squared ln x. And we have to let's take the derivative first of all. So I'm going to use the product rule. So first d second plus second d first. So it's going to be first. Well, I've got the equation now. Let me just have my target. So it's going to be first d second plus second d first, which would be 3x squared minus 4x. Simplify that, x squared minus 2x. No, not squared, minus 2x. Plus 3x squared, no, I'm going to keep that as a factorized form and then just do the product rule on it again. So that's plus ln x into 3x squared minus 4x. Cool. Now let's differentiate that again to get the second derivative. And we'll get 2x minus 2 plus, now I've got first d second plus second d first. So that simplifies to 2x minus 2 plus 6x minus 4 lots of ln x plus 3x minus 4, which then I can obviously combine and get 5x minus 6 into 6x minus 4 ln x. Now this whole thing is going to be equal to 0. Okay. No, so I'm fine, because this is my target. So what that means is I'm seeing a 4 minus 6x, so that implies I want to move the ln x to the other side. So that means that, well, 5x minus 6 is going to be equal to 4 minus 6x lots of ln x. And then it's just a case of rearranging. So x is equal to 6 plus 4 minus 6x ln x. And what I really should have done is to read the whole question to understand what was happening, because I thought we had to solve for x precisely, but this is clearly going to be like an iterative formula type of situation. Iterative methods question. Yeah. So using this iterative formula to determine the m coordinate, use an initial value of 1.1 and find it correct at 2 decimal places. So let me write that down for 5a part 2. We're going to have an x naught, I'll call it x1. So we have an x1 is going to be 1.1, and we need to find it to 2 decimal places using this. Now, this is going to be very simple. All I'm going to do is to, and this is very much getting a calculator out. So I'm just going to type 1.1 equals, and then just type out the equation that I'm given. So I'm going to be 6. Can't really see this very well. Not very big. Why don't I try it with the other calculator for a second? Maybe that'll look better. Nope. Don't do nonsense. So just, yeah, run stuff. Is that any better? Probably not. We'll find out. So I'm going to just type in 1.1 equals, obviously 1.1. And then I'm going to type out the equation as given. So 6 plus brackets 4 minus 6 answer. Where's answer on this calculator? Oh, there it is. It's the shift minus. Okay. 4 minus 6 answer, close bracket, Lun, you can so tell I'm more comfortable on the other calculator, which is probably why I need to spend some time with this one anyway. So Lun answer all over 5. And you can see I just keep on successively clicking equals, and I'm going to get a bunch more values. So x2, no. You are getting moved over here. So x2 is equal to 1.15049. I'll call it. X3 is 1.11864. And I need it to be correct to 2 decimal places, so I'm just going to keep going until the answers agree. And this means I never have to like retype it, which is just a very handy technique. 919, click again. And I'm just going to write enough that they know I'm actually doing this. So this would be 1.14. This would be 1.13. So we're getting close. We're not there yet. And great, we found 2 that agree. So therefore, these are both 1.13 to 2 decimal places. And so that is my answer for that. Okay. So now we need to determine the exact area of the shaded region, giving your answer in a form. So the exact area of the shaded region. Well, first thing I'm going to do is I'm going to rewrite what my equation is. So y is equal to, and I'm going to give myself more working room here because I know integrals, especially when they look like this, can get a bit wild. So the equation was y is equal to x cubed minus 2x squared into ln x. And we're going to find the integral of that. Well, to the shaded region, we have to find out where these 0 points are. So I'm going to factorize that. Now, where is the 0? We have clearly where x is equal to 0. And it's a repeated root, which is why the gradient is also 0 there. So we have this turning point at the origin. We're going to have x is equal to 2, which will be this guy here. And ln x is equal to 0 when x is equal to 1. So the shaded region is going to be between 1 and 2. So we need to therefore find the integral from 1 to 2 of ln x. I'm going to write it like this because I know that this is going to be a by parts. Because whenever I'm integrating anything with ln x, I do it by parts where u is equal to ln x. So I'm going to write that u is equal to ln x. So u dash is 1 over x. V dash is equal to x cubed minus 2x squared, which means that v, when I integrate that back up, is going to become a quarter x to the 4 minus 2/3 x cubed. So that way, when I apply my by parts, I would obviously do this more to the side, but for the purposes of visual. So that is going to be uv. So it's going to be a quarter x4 minus 2/3 x cubed into ln x. Now that between 2 and 1. So uv, and by the way, if you're ever stuck on this, yes, I have this memorized. No, I did not need to have this memorized because this should 100% be in your formula book. Yeah, this is integration by parts. So it's uv minus v du dx. So moving this back across for the graph. Okay. So we have uv minus the integral of v du dx. So a quarter x cubed minus 2/3 x squared dx, also between 1 and 2. This will not simplify. So I'm just going to plug the numbers in directly and kind of do it in 2 parts. So this will be a quarter of, well, can't be bothered. 2 to the 4 is 16. So it's a quarter of 16 minus 2/3 into 8 into ln 2. And from that, I'm going... Well, ln 1 is just 0. So the second term will absolutely be 0. So I'm just going to put minus 0. And then for the second part here, we've got minus 1/16 x to the 4 minus 2/9 x cubed between 2 and 1. So this will be 4 minus... No! Okay, I got to be real careful now. Really, really careful, because that ln 2 is on both of them. So it's 4 minus 16 over 3, lots of ln 2, minus who cares lots of ln 1, because ln 1 is 0, minus, and then over here we're going to get 1 over 16 into 16, minus 2/9 into 8, and we're going to subtract from that 1/16 minus 2/9. So we're going to have... I should really spread this out more, because you're kind of getting the perspective of what like an examiner is seeing when they're marking it, and it's not the clearest, so I should give a bit more room, maybe spread my fractions over multiple lines. But this is... So that would be 12 over 3 minus 16 over 3 is minus 4/3 ln 2. Apologies, my tablet needs some charge. Minus... Now this would be 1 minus 16/9. Subtract from that. Nonsense. Right, so this is where I'm now going to go to the calculator. 1 over 16 minus 2 over 9 is nonsense. So it's minus 4/3 ln 2 minus... So 1 minus 16 over 9. So that's minus 7 over 9 plus 23 over 144. Because of signs. So minus 7 over 9 plus 23 over 144 is minus 89. So the whole thing becomes 89 over 144 minus 4/3 ln 2. And while I'm here, I'm going to sense check that because that area is below the x-axis, I would expect it to be negative. So 89 over 144 minus 4/3 ln 2 is negative. So sense check, feeling good about that. Let me check now. The second you think you're done with the question, reread it to make sure you've actually got over the finish line. Where P and Q are positive rational numbers. And Q is a positive integer. Okay, but this is negative because below the x-axis. So the actual area is the modulus of that. So therefore, I'm going to say that the actual true area is the modulus of that. Which is just going to be equal to the same thing. Because that's negative, I'll just flip the signs. So it's going to be of the form of 4/3 ln 2 minus 89 over 144. Is that in the form that they wanted? Yes. Perfect. Alrighty then. So that seems to be that question. We're moving on to question 6, which is parametrics, it looks like. So we have these. Find a Cartesian equation for C. You do not need to simplify. Cool. Finding Cartesians is going to be quite simple here. What we need to do is to do simultaneous equations and eliminate the parameter. In this case, the parameter is t, And as soon as I see that there is t inside the trig, I know I'm going to eliminate that using trig identities. So let's rearrange and say that sine t is equal to x minus 4k all over k. Let me zoom in a little bit so you can see it better. So that's from rearranging the first one. From the second one, I know that cos t is equal to y minus 2 all over 4. And I know that sine squared, so therefore sine t squared plus cos t squared equals 1. Now that is a Cartesian. It's only 2 marks. You do not need to simplify, so I'm satisfied leaving that. You are given that C is a circle, determine the radius. Well, that's why we don't need to... Well... Determine the radius, that's 2. I am going to simplify a little bit, because I'm going to need that in B. So I don't know exactly what they're going for here, but I'm going to multiply... How could that be a circle? Now that gets interesting. Because of the K. But you're given that it's a circle. But the only way it could possibly be a circle is if K is equal to 4. Oh, no, but that's... Okay. What am I going to do? Okay, determine the radius of C. Okay, so what I'm going to do here... Oh, no, this will be fine. Will it be fine? Why am I... I do not like... Because it just feels imprecise. Okay. I don't like it. Because okay, what's the equation of a circle? Let me just start by writing that. So it's going to be x minus x1 squared plus y minus y1 squared equals r squared. Or x minus a squared plus y minus b squared equals r squared for x1 and x2 or ab being the center of the circle. The problem is the k and the 4. I don't like it. I do not like it. Shouldn't really be too much of an issue. Okay, I'm just going to try my best here. So I'm going to multiply by 16k squared. And if I multiply by 16k squared, I'm left with 16 lots of x minus 4k squared plus k squared lots of y minus 2 squared equaling 16k squared. That's not of the form of a circle. Okay, I think what we have to do is we just... But then there wouldn't be possible coordinates for the center. There would just be a coordinate for the center, because if k was just equal to 4... Why? Because if k was just equal to 4, then we would know the center precisely. Hold on, let me look at the marks. So 2 and 2, this is not supposed to be that bad. Am I missing something? Let's do this differently. Let's do this differently. I am instead going to use the parameters to get coordinates on opposite sides of the thing, right? So I can see that if I put in t equals 0, I'm going to get coordinates of 4k and 6. And if I put in t equals pi, which should be on the opposite sides of the circle if it is a proper circle, I would get 4k and minus 2. So in other words, if I kind of sketch this out, well, those would be on opposite sides of the circle. Same x, different y. And then if I used pi over 2 and 3 pi over 2, that would get me the same y and the different x. But the point is, those are very much the top and the bottom of the circle. So therefore, I can say that twice the radius is equal to 8, and so r is equal to 4. I am glad I thought to do that. That was tricky to find how to navigate that. But that feels like a good 2-mark version for this. And it says, find the possible coordinates for the center of C. Well, I know the center of C by averaging these, being that simple. So the center of C, I know it's y is going to be equal, well, it's going to be the average, right? So if it's going to be halfway in between. So it's going to be at 4k and 2. I know that for a fact. So it's just a matter of working out what k is and to find the possible coordinates. So we have to find possible values that k can take. Well, what that implies to me, if the radius is 4, that implies to me if I put in t equals pi over 2, say, then I know I've got the coordinates here. Sine of 5k and 2. Which implies to me that because that is 1 extra k on from the center, which means that k is equal to plus minus 4 as expected, because that is the radius, therefore is k. That's the difference from the center to that point, should be the radius. Now, it's because of the signs, k could be plus or minus, so I'm going to say the center is going to be, find the possible coordinates of the center, it's either going to be 16, 2, or it's going to be minus 16, 2. That's my story, and I'm sticking to it. That I did not enjoy. But this graph, I do very much enjoy at first glance. And this is the graph for question 7. So we have this curve. At the points P and Q, the tangents are parallel to the y-axis. So this, to me, looks like implicit differentiation, because being parallel to the y-axis means that dx dy is equal to 0. So dy dx equals 0 if they're parallel to the x-axis, and dx dy equals 0 if parallel to the y-axis. So I'm actually going to integrate straight. Yeah, I'm going to integrate straight up with respect to y as opposed to x. I think that, like, I'll check the mark scheme, because you could also do implicit differentiation with respect to x and then take the reciprocal. I might show both methods. But let's start with the one I want to do. 2xy plus 2y squared minus k equals 0, where k is a constant. So if I differentiate with respect to y, I would be left with 5 dx dy minus, now first d second, the second dy is just 1. And I'm going to do this in a bracket so I don't get lost. So first d second plus second d verse would be 2y dx dy. Differentiate this with respect to y, you would get 4y. That would give you 0. Right-hand side gives you 0. And we know at P and Q that dx dy is equal to 0 as well. Where k is a positive integer, at those points the tangent is parallel. So we know that dx dy equals 0 at P and Q. And if I plug that in directly, that will be 0. I'll get minus 2x. This bit goes off to 0, plus 4y is equal to 0. Okay. Given that the difference in the y coordinates of P and Q is 3, determine the x coordinates of P and Q. Well, this gives us that 2x is equal to 4y, which means that x is equal to 2y. And if I substitute that back into the equation, that should allow me, so this condition is true of the points where the gradient is parallel to the y-axis. But I need to find out which points with that condition actually exist on the curve. So 5 into, now x was equal to 2y. So let's plug this all in. Minus 2x y plus 2y squared minus k was equal to 0. So 10y minus 4y squared plus 2y squared minus k was equal to 0. So moving this all to the right-hand side to keep the y positive, we have 2y squared, because that was minus 2y squared, move it over, minus 10y plus k equals 0. And given that the difference in the y coordinates is 3, well, that matters because if I solve this, I know that y is equal to minus b plus or minus square root b squared minus 4ac all over 2a. And I can take a 2 out of this. So this is be 10 plus or minus 2 root 25 minus 2k all over 4, which then becomes simply 5 plus or minus root 25 minus 2k all over 2. Now, the difference between those two y coordinates is going to be twice this guy. So we have 5 over 2 plus that root over 2, and we have 5 over 2 minus the root over 2. So in terms of like a y number line, we have 5 over 2, and our two things are at here and here, where you do the plus square root and you do the minus square root. So the difference between them is double this square root thing. So it's root 25 minus 2k all over 2, where the 2's will cancel. And so I get that the square root, the positive square root of 25 minus 2k is equal to 3, which means that 25 minus 2k is equal to 9, which means that 16 is equal to 2k, which means that k is equal to 8. Okay, so I found that. And I wonder if I'll go back and I'll put that back in. So 2y squared minus 10y plus 8 was equal to 0. Which means that y squared minus 5y plus 4 is equal to 0. And wouldn't you know it, you have minus 1, y minus 4 equals 0, which means y is equal to 1 and 4, which do differ by 3. And then we can plug that all back in to find x, because x was equal to 2y So x is equal to 2 and 8. Now, p is the first one, and q is the second one. So the x-coordinate of p is 2, and the x-coordinate of q is 8. That was fun. Okay, now I think we're going to get into the mechanics section. Yep. So it's going to start off easy and it's going to get harder. How are we doing on time? We are doing okay. We're about an hour in, which is exactly where we should be. Well, I should honestly have been faster. Let's make sure I have enough time to check. But here we go. So here, particle is moving with constant acceleration. So I'm just going to write this down. Acceleration is minus 5I plus 2j. At time t equals 0. Hold on a minute. This is not a good viewing experience, so let me improve that. Okay, so at time t equals 0, p is at the origin and has velocity that, find in terms of I and j the displacement at time t equals 2. So it's constant acceleration, so this is suvat. So why don't I... Okay, so this is suvat. Let me write out the suvat. S-U-V-A-T. Acceleration is minus 5I plus 2j. T equals 2. U is I plus 3j. And so S is equal to ut plus a half at squared. Ut plus a half at squared. So it's equal to 2I plus 6j, which is that times 2. Now t squared is 4, so it's twice the acceleration, minus 10I plus 4j. So it's minus 8I plus 10j, the end. Determine the speed of p at that time. Well, in order to do that, I am simply going to work out the speed. So v equals u plus at. Nope. So v equals u plus at. So it's u, which is I plus 3j, plus twice, because t equals 2, the constant acceleration of minus 5I plus 2j. So it's I plus 3j minus 10I plus 4j, which is minus 9I plus 7j. Now it wanted the speed, so to find the speed, I just take the modulus, not the modulus, the magnitude of that. So the speed is just basically Pythagoras. So it's the root of 9 squared plus 7 squared, which is root 130. Okay. Moving on to question 9. Two horizontal forces of 17 and 12 act along point O on bearings. Okay. Determine the magnitude and the bearing of the resultant force for 6 marks. What I'm going to do here is I'm going to resolve it into the vertical and horizontal and then recombine. So if I've got these guys, then resolving vertically, I've got 12 cos 20 plus 17 cos 50, which is equal to, now I'm gonna bring the calculator back across. I'm going to first get it back into degrees because that is just the biggest issue I see. And I'm going to do 12 cos 20 plus 17 cos 50. And that's 22.2037 newtons acting vertically upwards, resolving horizontally. We've got 17 sine 50 minus 12 sine 20. And the reason for that is cosine closes the angle, sine opens the angle. And if I'm taking the right direction as positive, then the 17 would be positive and the 12 would be negative. So the horizontal component we can now get 17 sine 50 minus 12 sine 20 is 8.9185 newtons. Just getting a scheduling text. Cool. Right, so we've got the vertical component, we've got the horizontal component. So we know this resultant force goes there, and I have not drawn that anywhere close to accurate. Jesus. Where we know it goes 8.9185 right, and it goes 22.2037 up. So in terms of magnitude in the bearing, well, the bearing is going to be from the vertical. So we want this angle theta, which is the same as this angle theta. The magnitude is going to be from taking the Pythagoras on that. So I'm going to say that the force is going to be equal to the square root of 8.91. Was that 85? Yeah. 9185 squared plus 22.2037 squared. I'm not going to show you that. You know how to do that. So root of 8.9185 squared plus 22.2037 squared. So the magnitude is 23.9 newtons. And the bearing is going to be given by this theta, which is going to be given by inverse tan of the 8.9185 over the 20, opposite over adjacent, 2037. And the inverse tan of that, again, you don't need to see my keystrokes on that, over 22.2037 would give me 21.9 degrees. So in other words, the bearing, knowing how to quote the bearing, is 0 to 2 degrees. Great. That's the magnitude in the bearing. We have a third horizontal force now applied at O. The three forces are in equilibrium, which means that the sum of the forces is 0. So state the magnitude of F. That's, oh, I didn't realize they had a full magnitude and bearing thing here. Right, let me just fill this in. So the magnitude was 23.9, and the bearing was 022 degrees. The magnitude of F is going to be 23.9. And the bearing, it's going to be acting in the opposite direction. So it's going to be that plus 180, which is 202 degrees. Okay. Question 10. This looks interesting. In the real thing, I would absolutely annotate on the question paper, so I'll do that here as well. So we got 5G acting down. We have tension acting towards the middle, tension acting towards the middle, mg acting down. We have a reaction force acting up. We have our x. It's a smooth horizontal ground, so no friction. One end, light inextensible rope. The other rope is attached to object 5, blah, 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 angle of 50, force of x, angle 20. You are given the block as an equilibrium, determine x. Okay. Well, this isn't going to be that bad if you're systematic about it. So the thing is in equilibrium, so nothing is accelerating. So for question 10, the first thing I can say from dealing with the 5 kilogram object is that tension equals 5g. And then I can resolve horizontally on the M object in order to say that T cos 50 must be equal to X cos 20. So X must be equal to 5 times G times cos 50 all over cos 20. You don't need to see my keystrokes. So 5 times 9.81 times cos 50 all over cos 20 is 33.55 newtons. 3 marks, yeah, that seems sensible for 3 marks. Okay. You were also given that the magnitude of the contact force exerted by the ground on the block is 147, so determine the value of M. So this is 147. 147, cool. So that is going to be done by resolving forces vertically on M. And resolving the forces vertically, I find that x sine 20 plus 147 plus t sine 50 is equal to mg. So I've just found x as being 33.55. And I've already, so sine 20 plus the 147. And we know that the t is equal to 5g. Sine 50 is equal to mg. Was there a way of simplifying this? I wonder if I can give the exact form, because x was equal to 5g cos 50 over cos 20. So I might actually put that in precisely, because I just like precise. So it was 5g cos 50 all over cos 20. And I say that because the sine over the cos is now going to give me tan. But we would just want to find m, right? So what's 147 divided by 9.8? It's 15. So if I divide by g, I'll get 5 cos 50 tan 20 plus this divided by g is 15 plus 5 sine 50 equals m, which I can then just type in straight up. So 5 cos 50 tan 20 plus 15 plus 5 sine 50 is m is exactly equal to 20, which I adore. Okay. And that's why I did it precisely, right? Because if I did it rounded, I would have gotten something that just like rounds and wouldn't have been anywhere near as good. Right, so now we're on question 11. Uniform rectangular lamina has a mass of 0.5. You don't get lamina so much in Edexcel. That's interesting. So length of AB is 2, length of BC is 6. It's in limiting equilibrium, so we've got friction equal to mu r, with corner A in contact with a rough horizontal ground, but D is a smooth vertical wall. It rests in a vertical blade, blah, 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 blah. So by taking moments, show the magnitude of the normal reaction force between the lamina and the wall is 1.24. So let's draw these forces on, right? So this is a uniform lamina, which means that the gravity is acting at the center of the mass halfway through. It's going to be 0.5 g acting downwards. We're going to have a reaction force at A. This thing would be slipping to the right, so the friction force must be moving to the left, which is going to be mu r. We've got a normal reaction force here at D, which I will call RD. We're going to take moments about A, because that allows us to ignore these forces at A that we do not know. Okay, so let's, for 11A, let's take moments about A. And we're going to say that the clockwise moment, which is RD times the distance perpendicular to the pivot, which is this vertical distance here. And given that that is 6, this is 6. So that vertical distance is 6 sine 50. So that moment will be equal to, that's the clockwise, the anti-clockwise moment would be 0.5 g. Now, what is the distance? That is an excellent question. What is that horizontal distance? Because I know, okay, let me do some geometry here, right? I know we got got a rectangle. We got this. I know that if that's 2 and that's 6, I can work out. I know it's going to the center is going to lie along these diagonals, right? So I can work out that distance. And I know that distance is 3. So that's going to be the hard part here, is to work out the horizontal distance there. So what I'm going to do is to say that this diagonal is the root of 6 squared plus 2 squared, which is root 40, I believe. Root 6 squared plus 2 squared is 2 root 10, which means that this thing is half of that, which is equal to root 10. That's one. Well, I could have got there because that, in fact, hold on. Let's make this a bit clearer. So if I draw a rectangle with the diagonals, I know these will be split in half, where that is 1, that is 3, that is root 10. I can work out that extra angle in there. I can work out that alpha. Because that alpha is inverse tan of a third, which is, so inverse tan of a third is 18.435 degrees. Ooh, apologies, there was a comment I missed. Use F equals MA. Nah, I suv-added it for the first one. So taking moments. Okay, so that is the angle. That's alpha. And then there's an extra 50 here, which means that if I redraw this now, that's the center of mass. That's A. There's a kind of right angle triangle there where that's 50. So the whole thing becomes 68.4 degrees. And I know that distance from the center of mass to A is equal to root 10. So the horizontal distance is going to be root 10 cos 68.4. This is kind of insane. And probably not the intended solution path, but I'm running with it. So root 10 cos of that thing is 1.1623 meters. Okay. So that, let me rewrite. I kind of lost my place now. So RD into 6 sine 50. Now this probably, oh, you are very welcome, sir. So equals 0.5 g times that horizontal distance of 1.1623. Chances are this just feels like OCR has lemon as a more standard thing. Edexcel doesn't, and I'm just working this out. But I imagine I'm missing a trick here. There's probably a much simpler way I could have done that. But let me just simplify all of this. So that times the 0.5 g gives me 5.7012, and 6 sine 50 is 4.596 RD, which means that RD is equal to 5.7012 over that thing, which is 1.24 newtons, which is what I was trying to find. That felt like too complicated for 4 marks, but whatever. Determine the coefficient of friction between the lamina and the ground. Well, that is, so equilibrium, one part is always moments, one part is always resolving forces. So resolving vertically, we find that R is equal to 0.5 G. We find resolving horizontally that RD, which is 1.24, equals mu times R, which is mu times 0.5 G. So mu is equal to the 1.24 we just found as the reaction at D, all divided by 0.5 G. So take that, divide it by 0.5 times 9.81, and you're left with 0.253 to 3 significant figures. Can you show the question again? Yes, the question in this case was to find the coefficient of friction. Okay, so I've done that. Moving on to question 12. Okay, so we have to sketch the velocity time graph between 0 and 9 given this. So, okay, this is just a piecewise function. We've just got to plot this where k is a positive constant. Let's have a go. So, let me zoom out of here. Damn, that's insane. Okay, so we got a velocity time graph for 0 and 6. We can see that this will have v equals 0 when t equals 0 and when t equals 3, and is going to be a positive t squared graph. So it looks like t should be negative, assuming k is positive k. So it's going to be a quadratic through to here. And from there, it's going to go as 1 over t squared Apologies. That was up to 3, certainly, but it does go beyond that. So if that's like sort of 3, it's going to go, I'm just going to draw a quadratic. So it's going to, nope, third time's the charm. So it's going to go, it's going to be a quadratic up to 6. And from there, it's going to become a 1 over t squared. So that's going to be 3. That's going to be 0. That is going to be 6. That is going to be, when I plug in t equals 6, well, 54 over 36 is equal, so that should be 1.5k. Is it also 1.5k on the other guy? So when t equals 6, answer into answer minus 3 all over 12 is also 1.5. So it does that, and it ends at 9. And what's 54 over 81? So I'm going to say that's 9, and then that's 2/3 k. So that's my sketch. 3 marks. I think that's sufficient for 3 marks. I don't think I need to give the minimum. State the value of t when the acceleration is 0. Well, the acceleration is dv dt. So where is the gradient 0? I know that's going to be when t is equal to 1.5. Just from the symmetry of a quadratic graph. That's why it says state. So you're given that the total distance traveled by p in the total interval is 84. That's distance traveled totally, not displacement. So we got to work out the value. Okay, so the distance is area under the curve. So the total area is 84. So I'm going to write that down. Area is 84. So now I'm going to have these guys at the ready. And I'm going to zoom in. So let's first find out between 0 and 3. So the integral of this guy between 0 and 3. So 1 over 12k into t squared minus 3t. And we're integrating with respect to time. That will give me a 12k coming out the front. And then I'll integrate this guy into a third t cubed minus 3 over 2t squared. And that's all between 3 and 0. So that would be a 12k into 27 over 3 is 9 minus 27 over 2, it looks like. Hold on a minute. Let me just plug this in. So 3 equals, and then I've got a third answer cubed minus 1.5 answer squared, which should leave me minus the zeros. So it's a 12k into minus 9 over 2. So it becomes minus 9k over 24. It's good that it's negative because it is below the x-axis, which is what we expect. So that's part 1. I'm actually going to scroll across to get the second part of that. So we can see from the curve, we just found this negative area. We now need to integrate to find the area between 6 and 3, and then integrate to find the area between 6 and 9. So let's find out the same integral between 3 and 6. So it's going to be exactly the same integral, but with different limits this time. So it's going to be a 12k into a third t cubed minus 3 over 2t squared, this time between 6 and 3. And I plug that in, I'm going to get 6 cubed over 3 is equal to 72. 1.5 times 6 squared is 72 minus 54. I'm going to subtract off from that the value I got with 3, which was 9 minus 27 over 2. So it's going to be a 12k into 72 minus 54, which is 18. And this guy was minus 9 over 2, so it's going to be plus 9 over 2. So 36 plus 9 is 45. I'm just going to run it on the calculator. So 18 plus 9 over 2 is 45 over 2. So it's going to be 40. Now that times 1 over 12 is 15 over 8k on that one. And now finally, we need to find the integral of between 6 and 9, 54k t to the minus 2, which is going to be raise the power by 1 to get it to minus 1, divide by the new power. So it's minus 54k t to the minus 1 between 9 and 6. So that's minus 54k over 9 minus the value when I put the 6 in, so minus 54k over 6. So that's minus 6k plus 9k, which is 3k. So let's add up all these areas, right? So the sum of these areas, so 3k plus 15 over 8k plus, so that area was negative, but remember the total distance is 84. So that we need the positive area. So plus the 9/24, and 9/24 does simplify to 3/8. So plus 3/8k, and that total is equal to 84. So 3 plus 15 over 8 plus 3 over 8 is equal to 21 over 4k is equal to 84. Divide both sides by 21. Well, rather, I'll just do 84 divided by that thing. And so k is equal to 16. That was a lot of work. Right, moving on to 10. Nope, that's not 10. That's page 10. This is question 13. How much time? Half an hour left. We're all good. So 13. Okay, so let me zoom out so I can read it. So points A and B are the lower and upper ends, respectively, of the plane where we have an angle and a distance. It's projected up the plane with a speed. The plane A is fixed to the ground. It's a rough plane, and we have the coefficient of friction, and we want the speed at B. Now, I'm not going to use a further math would have me using energy here. I'm not going to use energy here. I am going to use forces in suvat here. Am I though? Ooh. Am I going to use energy? How am I going to handle this? Because I don't want to. So you want to show that the speed at B. So we got to find the speed at B. Okay, so I'm going to write down the information on the diagram. So sine theta is 0.6. Mu is equal to 0.25, I believe they said. Yeah. Okay, so let me just start by writing what I know. So, oh, do we not know the mass of A? I suppose it doesn't matter. Okay. So we're going to have mg acting down, reaction force acting perpendicularly, mu r, so a quarter r acting down the slope. Oh no, it's not going to be too bad. Okay, cool, got it. Right, so we are going to resolve forces. So resolving perpendicular to the slope, we have that r is equal to. Now, if that is theta, then that's 90 minus theta, then this is also theta. So we're going to have r equals mg cos theta. Now, if sine theta is 3/5, we can draw, I'm going to move across to handle this situation. We can go across, draw a triangle for which that would be true. So opposite is 3, hypotenuse is 5. Just from simple Pythagoras, we know the adjacent would be 4. And so cos theta is equal to 4/5. So it's 0.8 mg is equal to r. And then resolving, I'm going to resolve down the slope because I know that's where the resultant force is going to be acting. We know we're going to have F equals ma. So the resultant force is going to be a quarter of r plus plus mg sine theta, and that will be equal to ma. The m's will cancel. So a quarter of 0.8 is 0.2. But I'm still going to belt and braces that. So 0.2g plus sine theta is plus 0.6g is equal to a. So a is equal to 0.8g. So we know the acceleration on the slope. We can do a suvat. So suvat, I know the acceleration is going to, so I'm going to say that's up the slope is positive. So a is going to be minus 0.8g. The distance up the slope is 1.375. The initial speed is 6, and we want to find v. So v squared equals u squared plus 2a, nope, 2a s, cool. So that's 36. God, why am I illiterate? Why am I illiterate though? So 36. All right, let's work out this guy. 2 times 0.8 times 9.81 times 1.375. Cool. And that's all subtracted. So that guy minus 21.582 equals 14.418. Square root that, you get 3.80, which I'm really hoping is what we were meant to find. Yes. Okay, good. So we found the speed. Okay, not too bad. See, if in doubt, just work on the diagram and then it guides the way. Oh, it's the final question. I thought that we were going to get a question 14. Oh, that's taking me by surprise. So the particle leaves the slope at B and moves freely under gravity. How much time have I got left? Great, plenty of checking time. So particle leaves the slope at B and moves freely under gravity. The particle first lands at point C on a horizontal ground. The time taken for P to travel from A to C, not from B to C, from A to C, is t seconds to determine the value of t. So in order to do that, we need to split this out into the 2 episodes. We need to work out the time taken to go from A to B, and then work out the time taken to go from B to C. So let's start by getting that first part of the time. I'm not going to go... Oh, no, I am going to go by V equals U plus AT. Normally, I would advise to use SUVAT equations that use given values, not values that you've calculated yourself. Because if you have calculated it yourself wrong, that error would be carried forward into your working, and you would make a mistake. This time, though, they have confirmed that that answer is correct, so it is safe to use that value. So I'm going to use it. So I'm going to say, from that SUVAT, can I be bothered to do that in a whole different... I'll do it properly. 1.375. U was equal to 6. V was equal to 3.7971, because precision. A was equal to minus 0.8 G. And we wanted to work out the time. Now, I should also clarify, that is for the A to B episode. So here I'm going to say V is equal to U plus AT. So 3.7971 is equal to 6 minus 0.8 GT. So 0.8 GT equals 6 minus that thing, which is 2.2029. And then that thing all over 0.8 times 9.81. T is 0.2807, because I'm just going to be extra precise. So that is the time taken to get from A to B. Now we need to work out what happens going from B to C. So we know it's launched off at a speed of 3.8, basically, meters per second. We can split that. This is a now projectile. We can split that into the vertical and horizontal. Yes. So now let's consider the B to C episode. In the vertical, we can do another SUVAT, where going from B to C vertically, it's going to travel downwards by 1.375 sine theta, because that is the vertical distance there. Which, by the way, we can plug in because we know that sine theta is equal to 0.6. So 0.6 times 1.375 is minus 0.825 meters. We know that this initial speed at B vertically is equal to the 3.80 sine theta. So it's equal to that initial speed we found times 0.6. So 3.7971 times 0.6 is 2.27826 meters per second upwards. The V is irrelevant. The A is minus 9.81 because downwards. Look how careful I am with my signs, by the way. S is negative because down. U is positive because up. A is negative because down. And here we do not know V. We have to work out the T from the quadratic equation. So we know S is equal to UT plus a half AT squared. So minus 0.825 equals 2.27826 T minus 4.905 T squared. I am not solving that. Like listen, sue me. I'm going to be, could I type this into a quadratic formula? Yes, I could type this into a quadratic formula. I really trust myself to do that. However, no. So what I'm going to do instead is I'm going to use my cheating calculator. Yay. So if you do have your graphing calculator, and if you don't, I suppose you can come here and sort of work out what's happening. So shift, nope, menu, yes, equation, yes. Let's go. So here we're going to solve on a polynomial. It is degree 2. A is equal to 4.905. B is equal to minus 2.27826. C is equal to minus 0.825. Let's solve. So I get that T is equal to 0.7035 seconds, or T is equal to minus 0.239. T cannot be negative. So therefore I have my time. So therefore the total time is equal to that 0.7035 plus the 2807 to get from A to B. So running that, I get 0.7035 plus 0.2807, and I should, so I'm going to say 0.98. Does it tell us how many significant figures? No, I'm going to give it to 3 significant figures and say that's my time, which means I'm done with the questions. All right, which means we get into checking mode. Theoretically, there are 20 minutes on the clock. I'm going to give myself a little bit extra because I've gone a bit slower to be able to explain this properly as I go. Now, first thing I always check, it's not as necessary on the OCR, but I'm going to do it anyway, is to check to make sure I have answered every part of every question. More so on OCR, it's easier to accidentally miss parts, but here it looks like with a quick scan, I have working in every single answer box for every single part of every single question. Now, that doesn't mean that I've necessarily answered them correctly or fully. That's something I'm going to check in the next part. But yeah, looks like I have. Great. Nice and simple. Now let's go through and check the answers proper. So I'm going to go right back to the top of the question paper and then start going through with my answers, showing you how in a real exam I would check to sort of quickly make sure that everything is okay. So the first thing to do is to check on this would be to plug in a value. So let's say I'm going to go back to my normal calculator. So for this one, I'm going to try, I don't know, 0.26. No, yes. No, I'm going to try 1.4. So I'm going to try we're going to do 2 answer squared cubed times 0.75 answer. Where's the minus 1? swear that's a button. Oh well. Power of -1. So that answer gives me, I'm going to make a little note of this, 32.26944. When I plugged in 1.4, let's plug in 1.4 into here. 6, or sorry, rather, I'm going to go back and do 1.4 equals 6. Answer to the 5 is the same number. Bam, those are the same. Great. Simplify each of the following. So this one, I'm going to do the same thing. I'm just going to plug. Yeah, I'll do 1.4. But this time, actually, what I should do is say I'm going to do this thing on the left minus my thing and make sure it comes out to a cool 0. So 4 answers squared minus 9 all over 2 answers squared plus 5 answer minus 12 all into 2 answer plus 3 minus 1 over answer plus 4 gives me a cool 0. Great. So that's correct. For this one, so the area of the sector is less than that thing. The radius is that thing. Let me try representative value, for instance. So find the set of possible values. Well, no, first let me check my working and see if I think anything is silly. So half r squared theta. That has to be less than that. What I can do is I can come over here. I'm not skilled enough to graph it, but I am skilled enough to put it in and check. So repeat this time. Let's say A is 9. B is minus 38. C is that. Let's solve that. Yeah, 4 and 2/9. Good. So I did sketch that correctly. So it's in between because I want this thing to be less than 0. But I should also now check. So let's put in a representative number. So for instance, let's put in x equals 1. If x was equal to 1, the radius would be 4. The area would be equal to a half r squared times theta. So the area would be exactly 16. And if I plug in x equals 1 into here, I can see that 16 is less than that. So I have picked a number in the right region. So I am confident on that answer. So expand this and up to x squared. Well, that's going to be very simple. What I'm going to do is I'm going to plug in. I know this is valid for x is less than 1.5. I'm going to pick a value of x equals 0.1. I'm just going to plug it into both sides and show that I get roughly the same thing. So coming over to here, 0.1 equals, and then I'm going to do 3 minus 2 answered to the minus 2. And I'm going to make a note that that is 0.nope. So 0.12755. And if I plug in 0.1 into this guy, I get a 9th plus 4 answer over 27 plus 4 answer squared over 27, which gets me pretty much bang on the money, which implies to me that is a good, valid expansion. The expansion I have done correctly. It's for when the modulus of this thing is less than 1. Now for this one, I'm just going to plug my value of A back in and make sure my expansion gets me the right thing. So it was a 9th, 4 27ths. If A is equal to minus 3/4, then I would have a 9th, 1 over 9, minus 3/4 into 4 over 27, which does give me the 0 that I want. So that value of A is correct. For question 4, it's a show that. I did show that. I feel good. Nope. Solve this equation. Well, that's very simple. Let's plug it back in. So I have my 2 answers. Let me swap back into radians mode and plug them back in. So if theta is 0.101, we're going to do 2 cot squared. So that's going to be 2 into cot is cosine 2 theta all over sine 2 theta. That's going to be cot squared minus 9 over sine 2 theta minus 3 should get me something very close to 0. It's not that close to 0. But I suppose it could be worse. And let's take 1.470 and do the same thing. And I should also get something close to 0. So 2 into cot is, so let's take cosine of 2 theta, sine 2 theta. So that's cot. We're going to square it, minus 9 over sine 2 theta minus 3. Again, that gives me something very close to 0, so I feel good about that answer. So I've plugged them in. I think they are correct to 3 decimal places. Small angle approximation, I used it to find 0.10, which was the same to 2 decimal places, so I feel good about that. Show that, so you always just feel a bit more secure. So for instance here, I did do the show that. I feel a bit more secure. You find the coordinates of M. So how am I going to do this? Okay, let's plug this value of x back into the second derivative equation and confirm that I get 0. So that was this guy, this 5x. Okay, so let's put in 1.13. So 1.13 equals, because you always want to find some sort of way of checking it that isn't just repeating your work. So let's do 5 answer minus 6 plus bracket 6 answer minus 4 into ln answer. I should get something close to 0. Yes. So I feel good that that answer is correct to 2 decimal places. Determine the exact area of the shaded region. That really is just do the integral again. Or if you have a fancy pants calculator that can do it, you just plug it back in to confirm. I do not know how to use my fancy pants calculator, so I am going to confirm my working. So here we have our y's. That is the correct y equation. Good. We are going to integrate that between, so the zeros are 0 and 1 and 2. I am good on that. We're going to integrate it between 1 and 2. So integrate that to give me, so integrate that guy. You get a quarter thingy 4. Yeah. Minus that times 1 over x. Good. Plug in the 2. Let me just plug that in directly just to make sure nothing silly happens. So 2 equals, and then we're going to say 0.25 answer to the 4 minus 2/3 answer cubed times ln answer. That don't seem right. Okay, so 2 equals, so 0.25 answer to the 4 minus 2 answer cubed all over 3 is minus 4/3. So it's minus 4/3 ln 2 minus who cares ln 1 because ln 1 is 0. So I like that. The integral of that, raise it to 4/16 raise it to 3, so 2/9. Okay. So I'm going to do 2 to the 4 all over 16 minus 2 times 2 cubed all over 9. I'm going to do that in a bracket. And I'm just going to plug it in all in one go. I'm going to subtract from that what happens when I plug 1 in, which is 1 over 16 minus 2 over 9. And that gets me minus 89 over 144. Good. But I'm subtracting this guy, so that's why it turned into plus 89. Good. But that was negative, and so you have to flip the sign, and you get this, which is of the form that they wanted. Yes. They're positive rational numbers. Good. Okay. So for 6a, I'm really pleased with the solution path I found here. But let me check it. Find a Cartesian. I know how to do this. Sine and cos, are those correct? That's correct on sine. That's correct on cos. So sine squared plus cos squared equals 1. That is a Cartesian because it's only an x and y, and I do not need to simplify. You are given that C is a circle. I like what I did here to say that it's going to happen when t is equal to 0 and pi. So plugging that in, I am confident on the fact that the x values would be the same, which means that yeah. So that means the radius is equal to twice the radius. The diameter is equal to 8, so the radius is equal to 4. And the possible coordinates for the center of C well, let me just check that. So if that was the case, then I would be getting yeah, you get 3k, so it'd be minus 12 minus 20, which gives you a radius of 4. You'd be 20. Yeah, these are definitely correct. So that feels good. Now for 7, so we have, well, if I go right to the bottom, I have my x and my y's. So 2, 1, and 8, 4. I suppose what I could do is I could now go back, plug those in. So given that the difference between the y coordinates is 3, which is true, I suppose what I would need to do is to show that both of these actually lie on the curve, first of all, where I said that k is equal to 8. So let me start there. Let me make sure these points both lie on the curve. So I'm going to say so 5 times 2 is 10. Well, no, I'm just going to 5x minus 2x y plus 2y squared. I know this is redundant, but still, minus, and k was equal to 8. That point does lie on the curve. 5x minus 2xy plus 2y squared minus 8 also gives me 0. Great. Those 2 points do lie on the curve. Their y coordinates are separated by 3. Now let me just plug them in and check to make sure. And in fact, what I can do is I can show you the other way this could have been done. So the other way this could have been done is by differentiating with respect to x, which would give me 5 minus now first d second plus second d first plus 4y dy dx equals 0. We would need to rearrange to find dy dx and kind of flip it. But I prefer how I did it to do x dy. But whatever, let's kind of roll with it. So 5 minus, and I'm going to just call it y prime for now, minus 2y plus 4y y prime equals 0. So 5 minus 2y equals y prime into 2x minus 4y. So 5 minus 2y over 2x minus 4y is equal to dy dx, which means that dx dy equals 2x minus 4y all over 5 minus 2y, which equals 0, which gets me the same x equals 2y. Or rather, I have my dx dy. I can just plug in my 2 points now and show that does give me 0, right? So the points were 2, 1. So if I plug in 2, 1 into there, I get 0. And if I plug it, so whenever x is equal to 2y, it will give you 0. So this is correct. This is correct. It's correct. The end. Full stop. Done. Great. So then we move into the mechanics checking. Now, I'm out of time now, but again, I'll give myself some leeway to show you what you would do if you were moving a bit faster. So this is simple suvat. It's constant acceleration, which means suvat. So s equals u t plus a half a t squared. Twice that. Good. Yep, like it. So v equals u plus at is minus 9i plus 7j. So the speed is the Pythagoras on that. I like that. I really like what I did here on 9, where I resolved vertically and horizontally. Let me just basically check it again. So 12 cos 20 plus 17 cos 50. Correct. 17 sine 50 minus 12 sine 50. Oh. No, 12 sine 20. Good. That's the vertical, that's the horizontal. So you put it all together. Root of 22.2037 squared. 8.9185 squared equals that thing. Great, that's the force. Bearing, I'm happy with how I did that with the inverse tan. I will just rerun it just in case I ran a calculator error the first time. 22.2037. Yeah, so that's 22 degrees bearing, sort of up there. And then if the third. Now, as I was reading this, by the way, I was really put off by the idea that they said it was a horizontal force, because I was like, wait, that's not horizontal. And then I realized, oh, wait, this is in like a horizontal plane, because the other two are considered horizontal as well. Don't worry about that. But the point is, it has to be equal and opposite. So it's also 23.9, but in a completely opposite bearing. So acting in 180 degrees opposite direction. So if you add 180 degrees to that, you'll get the 202 degrees. Cool. So here, determine the value of x. How do I check this then? I agree that t equals 5g. Well, I suppose what I would do is I would work backwards, right? So if I had, let me work out the tension and make sure the tension I get from this is actually 5g. So 33, in fact, no, I will bring this back so you can see what I'm up to. So 33.55. Make sure, nope, I'm in radians. Let me make sure I go back to degrees. Look how much you have to check, right? Every single time you're going for trig, make sure you know what your argument is. So 33.55 cos 20 is a value, and that should be equal to t cos 50. So answer over cos 50 should give me my tension, which should be around 5G. So that I'll take the difference between that and 5G and make sure it's very small. Great. So that value of X feels good. Determine the value of M. Well, what I'm going to do then is use my value of M to work out the magnitude of this reaction force. So if I have so X was equal to 33.55. So resolving vertically. Well, actually, I'm just going to plug my M back in and make sure I get 0. So 33.55 sine 20 plus 147 plus 5G sine 50 minus 20G should get me very close to 0. Good. I like. So I feel good about my value of M. 11. The first part was a show that, so I feel good about that. Determine the coefficient of friction. This, I'm going to be just so for real right now. In the real thing, I would probably not even check that because I'm like, God, that was involved. Like this would be the last thing I would check because just this whole process felt bad. And I just feel like, again, at Laminas, it just feels like I was missing like a trick from OCR because I'm so used to the EdXL. But I like the idea that that was 3, that was 1, which means I can get that angle, add it to the 50, and then that was root 10. So root 10, no, I do like it actually. So inverse tan of a third. But it just feels like with some practice, like some of you guys out there are going to be much more fluent than I was on this question. So I do like that it was root 10 and that angle was that. So I can get that horizontal distance is root 10 times cos of 68.4. That felt good, actually. And if that was correct, which it feels like it was, then that moment would be from A, 0.5G times that distance, and RD times that vertical distance of 6 sine 50. So I like, well, I mean, it worked because it got me the 1.24. So then determining the coefficient of friction, that was just done from vertical and horizontal, which wasn't too bad. So RD, so 1.24. So let me just plug this back in, right? So 0.253 times 0.5G does also give me the 1.24 to balance with the horizontal force. So I like this. This graph I like because I did the quadratic 0, 3, going up to 6, and then coming down as a 1 over t squared. When is the acceleration 0? That's when the gradient 0, which is at 1.5. Find the value of k. Well, that would be the integral from 0 to, I mean, again, you just kind of got to do it. So let me just check my working real quick. So raise the power, so with 3 a third, raise the power to 2, do that, plug them back in. So that's 27 over 3 is 9, 27 over 2, 9 minus 27 over 2 is minus 9 over 2. So that's divide 12. So that is minus 3/8 k. Good. Same thing, but with a 6. So 6 equals, and then, well, 6 cubed over 3 minus 1.5 times 36 is 18. So 18 minus the same minus 9 over 2 as before. So plus 4.5. It's 45 over 2 divide 12. I do agree that that is 15 over 8. And then integrating that was actually even easier. Raised to minus 1, divide by minus 1. So plugging in the 9, plugging in the 6, minus 6. Yeah, 54 over 6. Like this, these were easy numbers. So that was 3k. Add them all together. I just like that. I like that. And I showed that this was 3.8, which I like. Using the same numbers, which I should just check to make sure I transcribed correctly. which I did. V was equal to U plus AT. Well, what I'm going to do is I'm just going to plug the value of T back in and make sure I get my V. So U, in fact, let me just bring you along for the ride on that. So 0.2807, and then it's U plus A T. Yes, 3.80, which is what I wanted to see. And then for the B to C episode going vertically, it's 1.3, it's downwards by that. So let me just check that 1.375 times 0.6. Nope, let me try 1.375 times 0.6 is in fact 0.825. Good. 3.7971 times the 0.6. 0.27826. Good. That is the vertical speed. Good. And then we just plug in. So S equals UT plus half AT squared. I'm going to plug in my value of T that I found here, 0.7035. And I'll bring you along for this as well. So because again, checking technique is by far the most important thing in math. So it's really important I demonstrate this well. So U 826 UT plus a half A T squared is minus 0.825. So that time does work on this quadratic. So that time plus the 0.2807, I'm just going to run that again just in case anything silly happened. And nope, it is 0.984, correct to 3 significant figures. And that leaves me done with the paper. So that felt okay. Like there was some issue with that one crazy question with the circle that I just hated because I really wanted to get it into the form of a circle equation. But apart from that, this felt fairly standard fare. So now I'm going to go and correct it to make sure I didn't do anything silly or to see if any alternative methods that might have made my working easier for you guys to pick up on. So here, 6a to the 5, 1 over x plus 4. Perfect. Oh, I can never be bothered with set notation. You will never, ever see me write set notation. Guys, in the real thing, write in set notation. I've done my time. Nope. So, oh, I actually put that back in, but it's 9th, so I got the same thing. Good. And then for this, good. And then A is minus 3/4. Good. I showed that. Good. 0.101 and 1.470. Good. And you get 1. Yeah, which is the same as 2 decimal places. Great. Here, yep, I rearranged it well. 1.13. Good. So 4/3 ln 2 minus 89 over 144. Perfect. This was correct and I hated it. R is 4. Why does that mean k squared is? Oh, okay, so I suppose the denominators, so they argued it, what I was saying out loud, that those have to be the same. Oh, so it's k squared is equal to 16. Okay. And then, but they got the same center points. Okay. And then question 7. So basically, I didn't find the intended solution path, but I did find a solution path. So that, I suppose, is good in its own right. Now, XP is 2 and 8. Good. Now moving on to the mechanics. Minus 8i plus 10j. Good. I left it exact. Did they allow square root of 130? Great. So here, resultant force is 29.3, acting on a bearing of 022. Good. And the next part is, 3.9, acting on 202. 10A, I should have 3 sig figged that. Oh! My answer is different than their answer. Are they using 9.8? They might be using 9.8. Are they using 9.8? Let me just check that real quick. Because that's important, knowing what value you're meant to use. So 5 times 9. In fairness, I should have used 9.8 because that's what they use in Excel. 5 times 9.8, cos 50, all over cos 20. Yeah, okay, they're using 9.8. Apologies, team. I used the wrong value of G. Now we know. Okay. Right in spirit. M is exactly equal to 20. For 11, A, I was so curious. Yeah, what are they doing? See second guidance column. So what did I do? So equals 0.5 G. So I did not do it their way. What are they up to? Where's this 1.5 G coming from? 3 times... What did they do? So 3 and 1. Oh, okay. Well, that 3 is the distance from there to there. How does that... Okay, so this feels like some mark scheme nonsense, basically. This feels like how they train you to do it in OCR in a way that I'm not familiar with. Correct moment for the weight of a lamina. Okay, so this feels like, a standard OCR thing that I'm not used to. See appendix. I kind of did it this other way. Yeah. But apparently there's a pretty standard way. So it seems to be they used 3 cos 50 and 1 sine 50. I'm going to leave this just because I don't think I'm going to get a satisfactory explanation on that quickly. Like, I'd rather prep that. If you guys know this, if you're OCR specific, feel free to drop a comment explaining it. But yeah, this feels like something OCR specific to me. I did find a way to it, though. And the coefficient of friction is the 0.253 that I found. So I feel okay about that. So, yep. Good. 1.5 seconds. And K is equal to 16. Boom. So everything there was right. It's just I forgot I used a slightly inaccurate value of G. Was there any more? There was more. Hold on a minute. I am not done with this paper. I forgot 13. Okay, so you got your 3.8. Great. And then the time was 0.985. Good enough. I think this is again an issue with the G, the fact that I used 9.81 and not 9.8. So that is how to do a paper. That is how to mark a paper. So some comments on that. I would say, yeah, if you're doing OCR, certainly look at that lamina, which is different than the Edexcel. I would say note how I was checking my work there. I think that's something that's really important in math, because you're going to make execution errors. And so how do you find them, right? So you saw during that run, I spotted one of them as I was going, which is ideal, but that was only because the question helped me out, right? The question told me, oh, show that these two things are the same. And I went, well, they're not the same. But I only thought to do that because the question told me to. So what I would have done is I would have left that thinking it was fine. And when I put that answer in during my checking, I would have seen that it wasn't right at all. And I would have found it that way. So checking is really good to spot those execution errors and make sure that every mark you deserve to get, you actually do get. So that's really the main thing. Like, I mean, yes, doing the math is like important here, but I think my main project here is demonstrating good checking, which no teachers really have the time to show you how to do. So watching me go through that process, I think, is very helpful, and it's something I'm going to keep doing. Now, moving forward, I'm done with this OCR series. I think we've only got a few weeks to go, guys. Like, it's T-10. So I think I'm going to go back and do another run of Edexcels. I'm going to stick to just the straight A-level math. If you guys have any particular Edexcel A-level math papers you want me to go through, definitely drop it in the comments or in the Discord server so that I can have a go at those. If there are any particularly gnarly questions you want to just sort of see what my brain does when I see it sort of blind react for the first time. In the meantime, keep working hard, guys. I know you got like we're getting to crunch time. You can so tell. So I always January, February time, I'm like, ugh, because my happiness in life is like directly proportional to my proximity to the next important test. So like during the summer, there's basically no work. And so it's like, fine. But then as soon as you come back in September, it's like, right, the full entrance campaign is happening. You've got your ESAT, you've got your TMUA in the October cycle, then you're straight onto Oxbridge interviews, and then you're straight onto the January cycle. And then right after that, in like January, February, your next big thing isn't until IB at the end of April. So it always feels like a massive slog. But now we've got IB at the end in like 6 weeks' time. And sort of your final learning is happening. Once you get out of the learning phase and into the revision phase, then I start to perk up again. I'm like, ooh, it's coming. And I'm starting to play the game with my students of like, how many weeks until your first exams? So it's kind of getting there. Like once you hit that Easter term, that Easter vacation, you guys are going to be really in go mode, and a bunch of you are going to start going into exam leave. So yeah, hope you guys are finding it good, getting all that last minute learning wrapped up. And I hope you guys are sort of moving through well and locking everything in so you give yourself less to do in the Easter break when it comes to your revision. So hopefully you found that helpful, and I should see you guys on Wednesday for another physics sort of seminar series. What I'm going to do with those is eventually I'm going to throw those out to like AMA revision clinics once we get into sort of, April, Easter exam leave. But in the meantime, I'm going to keep going through, and we're starting to put polls in the Discord so you can talk about which topics you want me to do my kind of like seminar on. We got a few options, and we'll probably end up going through all of them, but it's just a matter of which order. So I'll see you guys on Wednesday. In the meantime, take care, have fun, work hard, and I will see you then. All right, bye-bye.